HVAC 360, episode number 59. Lessons learned. Coordination. Hey, welcome back, everybody, to another episode of HVAC 360. I am your host, Matt Nelson. This week, I'm going to take a break from the interviewing. We got done with a lot of the expo shows, expo interviews that we've done, and now I'm going to kind of get back a little bit into sharing some of the nuggets that I've accumulated over the years. What I'm going to talk about this week, I'm going to start some lessons learned that I've kind of gathered over the years. This week, we're going to focus on coordination. So it's a topic I covered as part of a presentation I did for a local ASHRAE chapter, and I think it was one of those things that in coming up with the idea for the presentation, I understand that not everybody has the opportunity to get out in the field and share in some of these lessons learned. You know, a lot of people come up to me and they say, "Hey, you know what? What exactly do you what are the number one problems that you see as a commissioning authority?" And, even though that's not necessarily an easy answer to give, I got to say that most of the time, it's a lot about coordination, and that's kind of why I wanted to cover this as the first lessons learned topic. So, let's start into why why it is that coordination is so difficult. From my viewpoint, I think it can be lumped into one of the two categories. First off, we have poor communication skills. As engineers, I guess we're not necessarily renowned for the greatest communication skills, but I go beyond this kind of this stereotypical engineering jargon. Sometimes it's just the matter of asking the right questions in the process. Did we get all the information? Do we get it documented? It goes back to an owner's project requirements or making sure that everything is documented between you and the owner, between you and other engineers, between you and the architect. Kind of lumped in that same thing. If you're producing a set of documents as part of an integrated design team, that is, it's a benefit to you, but that's not necessarily a benefit that everybody has. Some mechanical engineers, they work hand in hand with maybe an electrical engineer who's in their office, and they might have a separate architect that it does not work in the same office. Sometimes it's just a mechanical, and they're communicating with an electrical in another office. That's a kind of a huge hurdle to overcome when you're going through this coordination thing that you have for your project. You need to make sure that, and you need to spend extra time communicating back and forth between these certain disciplines, because the habit of individuals, just people in general, is really to be lazy. If they don't have to reach out, they're just going to stay in their little silo and they're going to work on their project. They're not necessarily going to over communicate with people that they're working with. A lot of times in house, you get kind of a rapport built with the different people that you're working with, and you kind of assume, and you kind of have gone through this process one or two times, so you kind of work around some of the difficulties that you may have in the past, or they may be able to kind of forecast exactly what things went wrong, and they might be able to kind of head it off at the pass there. On the flip side, aside from having these external communication issues that affect your coordination, there's a lot of internal processes that are also kind of a little suspect. I know that depending on the size of your firm, a lot of engineers may or may not have quality assurance or QA/QC, quality assurance, quality control in place. Now, QA/QC in general is something that's very critical, because realistically, when you're as an engineer, when you're going through the design, a lot of times you're too close to the design to be able to see some mistakes, some things that are painfully obvious to other people, and this is where I kind of take advantage of it as a commissioning authority, that I'm able to see some of these things that are not quite coordinated fully. But if you don't have that internal third set of eyes looking at a particular set of drawings, things might slip past. Typically, you're going to have in a engineering organization, you're going to have whoever is going to be stamping the drawings ultimately be responsible for the QA/QC process. Larger firms might have dedicated staff just for that purpose that are aside from the engineer of record. That would be the individual stamping the drawings. So if you do have that in place, fantastic. But a lot of times when you get down to these organizations that are, less than 10 people, it really becomes some sort of a difficult thing if they haven't made it very explicit that they have this process in place, and that kind of goes not only for an end of the project QA/QC process. They might do it at every level. It might be for design documents. It might be for the SDs. It might be for the CDs. They might do it multiple times, and not necessarily at the end of a project. But you might need a process in place to say, okay, you know what? First I'm going to, lay out a basis of the basis of design. And that was one of the things that I kind of snuck in there. I'm like, if you're going to have a basis of design, why not make it your SD set? Get a really good basis of design. So for your SD drawings, don't necessarily draw drawings. If you're going to do drawings, just do certain focused areas like mechanical rooms or something that's important that you get coordinated right off the bat. But if you have a good basis of design, that could substitute for your SD. And again, this is kind of one way to think about your process. So if you have a good process in place, it helps a lot, especially when you come to crunch time. And this is ultimately where it plays out. When you're doing coordination between different disciplines, that's the crunch time is when people start forgetting. It's just things that I've seen that are like, I know the engineers, and I know in talking with them, they just shake their heads and they just, I ran out of time. You have to be able to plan better and make sure that you have, whether it be a missing schedule or a missing detail that, clearly should be on the drawings to help out the contractor be able to price it better. Or, whether or not it had a set of control drawings in the set. It's something that you need to have in place just to have, a good way of thinking about, a basis design for the SD. For the DDs, we're going to draw X, Y, and Z, and we're going to have all that, laid out. I'm going to have, I'm going to have the schedules there. They might not necessarily be all filled out, but I'm going to have, model number and serial number for, or their model number and manufacturer for all the different schedules that you can put on a drawing, or I have all the details done. So that's one way you can develop the process, and again, have the finishing steps for the CDs, and kind of integrate how you're going to do quality assurance and quality control checks on your set of documents before they go out the door. I mean, that's going to be the best for you. So, I mean, barring that, that's really where I see. I don't see a lot of that. I don't see a lot of that in the smaller firms. I don't see a lot of that from different organizations that I talk to. A lot of times, you do get crunched for time, and when that happens, some people opt not to do the quality control that they know they ought to. So that's kind of where it comes down to me as a commissioning authority, and that's where I see it. But aside from why it happens, let's I want to dive deeper into a little bit about some of the lessons learned. Again, I want to communicate some of the lessons learned that I've gotten from coordination, and what are some things that you can possibly do to enhance or improve your coordination when it comes to a drawing set. I guess, first off, I want to talk about the difference or the coordination between the engineer and the architect. I think there's three basic things that really pop out at me as far as things that I've seen commonplace on multiple drawings. First is the coordination of the smoke walls and the fire walls. I mean, this is something that should be, that really affects people, especially when you get down into a situation where you've already bid the documents and you have a smoke wall that all of a sudden shows up on a drawing because the architect, that was some of the last things they did, to put together the set of documents, and the mechanical didn't pick it up and put that on there. Well, it affects the electrical as well. I mean, that's one of the things. It just keeps snowballing that, not only does, you have to put an electric power connection, now you have to get it integrated into the fire alarm system, and it just keeps, snowballing from there. So you want to make sure, as a mechanical engineer, you want to make sure that you talk to the architect and you have a drawing that's clearly labeled where all the smoke walls are. You want to make it painfully clear that this is something that you absolutely need. You need to know where the smoke walls are. You need to know where the fire walls are. And obviously, it's going to change around the world. It's going to change a little bit based on where your local codes are. But, I mean, obviously, these are kind of, basic things that you need to be looking after. Whether it be, locating these and locating above ceilings, you need access panels. Now you've got the general contractor involved, other trades. So it really becomes one of these things that can snowball. One of the things, too, and this is more of a U.S., again, internationally, I'll kind of, I don't know exactly what some of the problems are, but in the U.S., there's a situation that occurs when you have an exit stairway and it doesn't exit directly to the outside. So what you create is an exit passageway. Well, there's special rules and considerations that happen to these exit passageways. Well, a lot of times what happens, and this happens on jobs where there's multiple additions on a building. So a hospital is a great example of where this tends to happen. All of a sudden you put an addition onto a hospital, so an exit stairway that used to exit to the outside now can't and has to kind of go through the building a little ways, through this exit passageway, and get outside. Well, if you don't coordinate that with the architect, and the architect doesn't tell you, there's a whole host of things, a lot of costs that actually gets added on to the project, because basically this is a no-go zone for just about everything. It has to be completely self-contained. It has to have its own HVAC. It has to have everything has to be routed around. A lot of times if you catch it kind of after the fact, but before the bids go out, sometimes you can put a hard lid on the corridor so nothing's communicating exactly with the corridor, and you just put a fire rating over the floor. There again, if you have an exit passageway, sometimes it affects the structure. So you have to do different fireproofing to the structure, and again, it just compounds when you don't have that smooth coordination, that smooth communication, rather, between yourself and the architect. Another thing that happens is the coordination of exterior louvers. Now, again, louvers are one of the things that, as an engineer, you probably know everything about. The velocity, it needs to be drained, et cetera, but it tends to be one of those things where the architect ends up being the one that either specifies it or they have it installed and it's part of the general contractor's schedule of work. It's in their scope of work. They're going to have to install it. Well, what happens when there's a louver that needs to be put on the exterior of a building and the general contractor doesn't? All of a sudden, there's not a hole where you need there to be a hole. And again, it just compounds. It's one of those easy things that, especially when you look at a architectural elevation, architectural elevation drawings. Just take a look and make that coordination. I often take a look at them, and especially like some of the smaller ones. Typically, they're going to have the large ones. If they don't, that's going to be a huge problem. But a lot of times, they'll miss any sort of little louvers that are required from exhaust fans or other, other inline exhaust fans that you might have around the place. So get those coordinated, get those detailed right. You need to make sure that, and you need to figure out exactly, how you're going to be connecting to those louvers and get that as part of the detail. A lot of times there might be a discrimination between whether it's going to be a 4-inch louver or a 6-inch deep louver, and sometimes that makes a big difference when you're figuring in, if there's any sort of water infiltration into your space. So you need to take a look at those things and coordinate that with the architect. All right. Enough of the architect-engineer coordination. Now let's get into kind of the engineering/owner coordination. Now this I've seen a number of times pop up, but realistically, if you have owner-furnished equipment, also if you have kitchen equipment, I'll kind of throw that in the same vein. You want to make sure that you have that scheduled separately. Know exactly what the connections are, what kind of, cold water connections, hot water connections, if there's any special exhaust requirements, who's putting that in. Talk about kitchen, there again, something who's going to specify the hood? Is that in the kitchen supplier's bill of goods? Is that in their scope of services, or is that something that the contractor, the mechanical contractor is going to provide? Or are they just connecting it? And if they're connecting it, who's putting it up? I mean, it's simple things like this that really have to be thought through and coordinated, and it just takes an extra phone call to make sure that it gets on the drawing right so everybody's clear about what they're supposed to do. Again, it's all about clarity with this coordination. So from kitchen hoods, making sure that who specifies it, from getting the connections on different pieces of equipment, and again have them labeled, have everything tagged, and have it coordinated between the schedule and the drawing, so everybody knows exactly where these pieces of equipment are. Same thing I've seen between the mechanical and the electrical. I mean, this is a really a great coordination tool for the electrical engineer. Just to have, instead of having it buried in panel board schedules, have a dedicated HVAC list, having a schedule just for HVAC. So it takes all the HVAC equipment with their tags. It tells you what kind of electrical connections there are, whether or not you're providing the motor starters, the disconnects, any sort of motor control centers, any sort of specialty items that you would for the mechanical contractor. I mean, that way it's easy that when you have your coordination at the end of a project or in the middle of the project, when you're trying to get the drawings together, that the mechanical can sit down and say, okay, yep, I see it. It's all on the list. You didn't miss anything, and you can both reference that same list and make sure that yep, they got everything. One last thing, I guess, with the coordination, some of the lessons learned that I've seen in the field is the smoke control sequence. I mean, this is something that it involves everything from the architect. If there's smoke barriers, if there's smoke partitions, smoke barriers, smoke walls. If you're trying to kind of have a protective environment in a place, you need to be able to coordinate that with the operation of your HVAC equipment. Same goes true with the electrical. How is that going to interface with the smoke control, the fire alarm sequence? And to have that, do you have an atrium? Is there atrium part of a project? Again, a lot of this just needs to be kind of gone through with a fine-tooth comb, and you just make sure that you understand each one of the different components in sequence, and that you answer all the questions. Again, don't assume that something's going to be covered. Whenever I look at a set of drawings and I see a lot of kind of just cover your butt kind of notes that it's contractor to furnish complete system. That's pretty much garbage. If you want something on a drawing, you make sure that you better detail it. There's some things that you don't have to count. Specify the number of joints or the number of widgets are on a project. But I mean, if there's significant items, you better make sure that you know exactly where everything's going to go, because you need to make it clear for the contractor. Again, it's about being clear. It's about being fair. It's not fair for the contractor to do any engineering for you. It's not fair for your manufacturer's rep to kind of guess how many of a particular of fire smoke dampers there are on a project. You just can't delegate that task of counting them and making sure they're in the right spots just by saying contractor to furnish where appropriate. That's kind of a real bad cop-out. You need to be able to engineer and specify that. So based on that, one of the things that I kind of threw in here that kind of really is one of my pet peeves is tagging. And I don't know if I've kind of gone over and done this rant before, but it's worth doing again, if it's worth doing 1,000 times, that specific pieces of equipment need their own unique tags. And I've gotten to this battle royale a couple of times with a couple of the engineers. And this is something that I can't back down from, just from a standpoint of, say, for instance, things like all the unit heaters. If they have electrical connections, anything that has an electrical connection involves another discipline, make sure you have a unique tag for it. Because they're going to have a unique tag for it. Somebody will. And that's the issue. Somebody's going to have to make up a unique tag. Why don't you take the initiative and do that for everybody? Think of something that makes sense. It's your equipment. You're putting it on the drawings. You come up with a naming scheme that makes sense for everybody. A lot of times you have VAV boxes. This is very common. A lot of times you have VAV boxes, and they'll be scheduled by size. Well, that doesn't do a lot of good when you're looking at a drawing and you have 100 VAV boxes. All of a sudden, one of them stops working. Now it's going to be, when I put it on a issues log and try to identify something that needs to be corrected, it's going to be VAV box, size A, it's outside of room 206, and it's across the hall and a little, down north a little bit. You try to give these, reference guides using words, and it just doesn't work. You need to be able to say VAV box 1-02, doesn't operate, is not functioning properly. Now everybody knows, okay, it's 1-02, okay, that's right here. I see it on the drawings. Because if you do these referential kind of identifiers to pieces of equipment, it gets so complicated. You have, and I've seen it a number of times, when you start referencing, okay, well, it's going to be, say, a VRF unit that serves, room 268. Well, guess what? Room 268 was chosen by the architect when the official, sign maker comes on site and decides, okay, exactly what the rooms are going to be called. All of a sudden, 268 is now 278. And now you have to have this coordination, this cross-referencing schedule of what room was what and what does it change to and what is it now. And if some of them are the same and some of them are different, that makes things worse. Please, give unique identifiers to your equipment. In the one case that I went through, it ended up like this. He didn't want to back down, changing the size, changing his schedule. He didn't want to have to go through and do that. Well, I said at least give them unique identifiers, and you can keep that, that size moniker, but at least give them a unique identifier. Go through the drawings and just label them on the drawings. They don't have to tie back to a schedule. Just label them on the drawings. But even that's kind of not quite right, because is one VAV box size A going to be the same, the minimum setting? Is that going to be the same minimum setting as another VAV box A? I don't know. If you sized it like that, okay, perfect. But if you have a lot of different types of rooms that have special minimum airflow requirements, maybe you should think about just, biting the bullet and going to a full schedule with each individual VAV box labeled. It's going to be better for everybody. It's going to be better for the temperature controls contract. It's going to be better for the mechanical contract. It's going to be better by the equipment rep who actually has to go through and create a submittal based on what you've done. It really is a big issue with coordination. Another thing that you'll find is that if you are going on a project and you have multiple different additions to a project, guess what? Take a moment, figure out what the numbering system is, and leave off where the last project stopped. Okay? I've been to a number of projects where, you've gone in and, okay, I see air handling unit 1 there. I look over and air handling unit 1 in that room and air handling unit number 1. Everybody starts with 1. So there's air handling 1 3 times, and especially when you're trying to fix it, you're like, well, I went to air handler 1. Well, which one was that? And it's really difficult when you're trying to, figure out exactly, it was on the west side of the roof. Oh, no, the east side of the roof. What are you talking about? So try to integrate your numbering system with the existing equipment. If you have a new building, obviously it doesn't apply to you. But if you have an existing building where you're making an addition, take the numbering system off where the last one stopped. Talk to whoever is in charge of maintenance and figure out if they've actually come up with a different numbering system that they've changed in the building automation system. Maybe they like some numbering scheme that makes sense to them. Just adopt that. Make it easy on everybody. It makes the owner happier. It's he can look at the drawings and say, okay, I understand this because this is the way I number them now. So that's my equipment tagging coordination rant yet once again, I think. So anyway, I just wanted to give you a couple of lessons learned that I learned out in the field. Hopefully you got some benefit out of that. If you did, share it with a friend. I really appreciate you and each one of you taking the time to listen to this my podcast. You are the top 3% of your profession. Learning every day makes you stronger, makes you better. Learn and just share what you know, and that's what I'm trying to do here. I would like to give a shout out to JD, who actually left some great feedback for me on iTunes. I really appreciate that. Thank you, JD. And for anybody else, go ahead and leave me some comments. I'd love it. iTunes is a great place to do that. Give me a rating. Give me a little note. Give me a little review. I would certainly appreciate it. If you like this episode, pass it on. If you like these type of episodes, also let me know. You can email me at matt@buildingx.co. Lessons learned. Again, I think it's a great topic, and I might try to, get some more together for you to intermix between some of the interviews that I'm going to do. So, again, you want to get a hold of me, matt@buildingx.co, on Twitter @buildingx, and if you want to just kind of connect with me on LinkedIn, go ahead, Matt Nelson PE. On LinkedIn, excuse me. So, until next time, thanks all for listening, and remember, know what you build, and share what you know.